Bismillahirrahmanirrahim. Welcome to the lecture 3 of digital signal processing. Today I will explain system and basic signal. Now moving toward the system. System is basically a process to produce other signals from input to output of the system. Here X of n represents the input of the system and Y of n represents the output of the system, and this block represents the system. Types of system. I will explain three types of signal, that is causal system, linear system and time invariant system. What is causal system? Causal system is one in which output, which is Y of n, at time n depends only on the current value of the input. This is the current value of the input. And past value of the input, right? And this one is the past value of so causal system is one which depends on present and on the past value of the input. Now non-causal system depends on the future value of the input. Through example, it will more clear to us how non-causal system look like. So this is the example. If we apply the summation formula, then we have x into n plus 2 plus x into n plus 1 plus x of n plus x into n minus 1 plus x into n minus 2. As this system depends on the future value, these one are the future values of input. So this system is non-causal system. The second type of system is linear system. The concept of linearity links with the superposition principle. So the linearity means that the system obeys the superposition principle. Superposition principle follows homogeneity and additivity. So what is the homogeneity? Homogeneity is basically that if we multiply input with some constant, like I multiply input with constant alpha, so if the same coefficient is multiplied with the output, then the system becomes homogeneous. For example, I have y of n is equal to x of n minus 2 into x into n minus 1. This is causal system. Because it depends on the present and past values of the input. Let, in case of linearity, z of n is equal to alpha into x1 of n, and if z of n pass through the system, this one, then it becomes z of n is equal to z of n minus 2 into z n minus 1. By putting the value of the z of n, we got x into x1 of n alpha x1 of n minus 2 alpha x1 n minus 1. By taking alpha constant, this will be equal to output, that is y of n. So this system is homogeneous. Now we'll explain the second property of superposition principle, that is additive property. Additive property is the system output due to some inputs is equal to the sum of individual outputs. By taking example, it will clear to us that x1 of n represent x1 of n minus 2 x1 n minus 1, that's represent y1 of n, and x2 of n x2 of n minus 2 into x2 n minus 1 represent y2 of n. So let's in additive property, let's say z of n is equal to x1 of n plus x2 of n. By passing z of n through the system, it will become z of n minus 2z n minus 1, as discussed earlier. So by putting the value of z of n, we will get x1 of n plus x2 of n equal to x1 of n plus x2 of n minus 2x1 and n minus 1 minus 2x2 n minus 1. x1 of n, by arranging them, we will get this result as this one equal to y1 of n and this equal to y of 2 n, and this represents the additive property of the system. Now the third system, which is time invariance system. In time invariance system, the output doesn't vary with time and it is independent of time. In time invariance system, there should be the same shift in input as well as in the output of the system. But taking the example which I discussed earlier, y of n is equal to x of n minus 2 x n minus 1. In time invariant system, let zn is equal to x into n plus n naught. N naught is basically the shift. Likewise, z of n is equal to z of n minus 2 z n minus 1. So by putting the value of the z of n, we get x into n plus n naught x n plus n naught minus 2x n plus n naught minus 1, and this represents the same shift in both input as well as in the output of the system, and the system becomes time invariant. In time variant system, it is dependent of time and output vary with time, and there is not the same shift in the time variant system. Let's take an example. Y of n is equal to x into n square. By applying the shift x into n plus n naught, this output will becomes x into n plus n naught square. By applying square formula, this will becomes n square plus n naught square plus 2n into n naught. As it is clear that there isn't a same shift, so this becomes the time variant system. The second part of the lecture is the basic signals. There are two basic kinds of signal in digital signal processing. One is unit impulse system and second is unit step signal. Unit impulse signal. In unit impulse signal has a amplitude of 1 when time is equal to 0, and 0 for when amplitude of 1 when time is equal to 0, and 0 when n is greater than or less than 0. So it is represented by delta n as and the second signal is unit step signal. Unit step signal has amplitude of 1 when n is greater than or equal to 0, and 0 when n is smaller than 1. It is represented by u of n. Now I will discuss the relationship between unit step and unit impulse signal. By taking the derivative of unit step signal, we get the unit impulse signal as d into u into n into d of n is equal to u of n into minus u into n minus 1, as u of the graph of u of n looks like this, and the graph of u of n minus 1, there is a shift of plus 1, so it starts from 1, it's u of n, and it's u of n minus 1. By subtracting u of n minus 1 from u of n, we get the unit impulse signal that is at 0 and its amplitude is 1. This is it for today. Thank you.